Greetings and welcome. Today we are talking about our first of the trigonometric ratios, a concept that will continue in probably show up in Algebra 2, I believe it does, and pre-calculus as well. Ratios. Good stuff, good stuff. So today, 9.4, tangent ratio. This is the idea. A trigonometric, now that's a crazy word, trig, right? Think just like triangle, metric, measures. It's just talking about like the measures of triangles, okay? So don't be scared of the word trigonometry. Is a ratio of the lengths of two sides in a right triangle. All right triangles with a given acute angle are similar by the angle-angle similarity theorem, right? So you guys talked about that when we were doing the geometry sketch pad earlier. So in this sketch, triangle JKL, J to K to L, is similar to triangle X to Y to Z. And you can write that KL, all right, right here, all right, KL, actually, wait, I was going to color coordinate this. What was I going to pick for colors? I think I was going to do purple for opposite. Purple, here we go. Or I don't know, this is probably a fuchsia. I'm not like a color expert here. So KL corresponds to YZ, right? You guys agree? All right, Ty, you with me here? Right, JL corresponds to XZ, right there. And I'm going to refer to these from the angle that happens to be congruent, the acute angle here. So KL is to YZ as JL is to XZ. All right, this can also be rewritten as KL is to JL, right? Short leg to long leg is going to equal short leg to long leg for this triangle. So trigonometric ratios are constant for a given angle measure, right? Because we're always going to use trig ratios in reference to a right triangle. And so if my given angle measure is like 30 degrees or 35 degrees or 42 degrees, whatever, the ratio of this to that will be the same no matter how I scale up or down this triangle. And now here's one of these trig ratios. It's called the tangent ratio. And it is a trigonometric ratio for acute angles that involves the lengths of the legs of a right triangle. And this is what it's going to end up being. All right. Here we go. Tangent ratio. Here we go. So the tangent is a ratio between a very specific pair of sides for our triangles, right, gentlemen? So I've got, Evan, right? I've got the opposite leg right here, opposite leg, with respect to this angle A. And I'm referring to it as the opposite leg because it's on the opposite side from that angle. And then I've got the adjacent leg because it's the leg of this right triangle that is included in one of the sides of the angle A. All right, so those are the two legs that I'm referring to, and it's always in that order for tangent. So tangent is opposite over adjacent. All right, so tangent, actually you might even hear this later, is opposite over adjacent. TOA is one of the things that TOA is how I remember this. TOA, tangent, opposite, adjacent. Okay, so, and this is true for any right triangle in an acute angle A. Now, technically, I could reverse this on you and ask, what is the tangent of angle B here? So if I want, what's the tangent of angle B? What is the opposite leg for angle B's perspective? Yeah, that's going to be CA. So opposite to the adjacent, BC. All right, so it depends on which angle's perspective I'm talking about, and the ratio will always be the same. So first, I've just got to be able to set up these ratios, and then we'll start putting them to work to allow us to solve for previously unknown sides of triangles. Hooray! Okay, here we go. So find tan of S. Okay, so tangent of S, angle S, measured in degrees. So here's angle S right there. Which is the opposite for angle S? The opposite leg, it's going to be TR. So that's going to be 80 over the adjacent leg. Which is the adjacent leg? The 18. And I'm not going to be using the hypotenuse for tangent, okay? All right, and let's talk about what about tangent from angle R's perspective. So tangent of R is going to equal to what ratio? So here, this time my angle is R. The opposite is the 18 this time. And the adjacent is the, from angle R's, which leg is adjacent? The 80, right? All right, so it's adjacent leg. So it's never the, I guess, yeah, let me specify that. It will never be the hypotenuse. The hypotenuse is adjacent to this angle, but it's not a leg. All right. So let's put this to work. Let's look at example 2. Start get a little bit more interesting here. Ah, that's exactly where I wanted to go next. Now, guys, if I gave you 2 side lengths of a right triangle, you could find the third side using what method? The Pythagorean theorem will take the inputs, the parameters of 2 side lengths of a right triangle, and give you the third side length. The benefit of these trig ratios is, notice this, I do not know 2 side lengths for this triangle. I know 1 side length and 1 of the acute angles. And with this information, I will be able to solve this right triangle. I will be able to find the missing information. So let's see, my angle is 32. Okay? And I'm going to set up a tangent ratio here. So I'm going to say tan of the 32 is going to equal what over what? So my angle, measured in degrees right now. Later on in other courses, you'll have other units of measure for angles. And the opposite, right, opposite leg is 11. And the adjacent leg, right, leg specifically, is going to be the x. And so now once I set up this ratio, all right, I can now solve for x. Now tangent of 32 is just a number. It's going to be some decimal value, an approximation that your calculator will store in its memory, or that you could find in the table of the back of an old math book. For some reason you were ever looking through one. And I want to solve for x. You could put tan 32 over 1 if that helps and cross multiply. That's probably the simplest way for us to think about this. So I'm going to have x times tan 32 is equal to 1 times 11, which is 11. So now x is being multiplied by some number, all right, is what tan is. So how could I get x by itself? Well, it's being multiplied. But right idea. Thank you for trying though. Tan of 32 degrees. And how do I divide that? Well, these cancel out. And I'm going to get x is approximately, and in my calculator, I'm going to type in 11 divided by, there's a tan button, and 32. And I get about 17.6. And they said round to the nearest tenth, so I'll leave it at that. Did you? Do not hit the tan to the -1. It's the same button. Okay? Here, let me tell you what. just to make sure that we're all on the same page, I need to make sure that 100% of us can get this value here. So here we go. So in order to do this, I did 11, right? Divided by, and now I've got 3 trig ratio buttons. Sine, cosine, and tangent is what sin, cos, and tan stand for. And I'm going to hit tan of 32. Probably a good idea to close those parentheses. And when I hit enter, I end up getting my approximation of 17.6. Now, yours might be working in a different angle measure. Now, what is now if you could for me, what is tan of 32 on your calculator? I'm going to come around and make sure everyone gets the same thing. Anthony, is your calculator ready? Calculator. Got it on my. Or would you have to write that? Oh, good. Yep. Don't worry about it. We'll talk about it. We'll talk about it. All right, let's go back to our seats, friends. Chop, chop. Because I've got a lot more to show you. So, if Anthony, Evan, Aiden, Ty, Josh, Haley, let's go. Ty. Second time, Ty. All right, so Malik, one of the issues that your calculator might be having is it might be working in something other than degree mode. Notice that mine says DEG for degree. Just like there are multiple ways of measuring distances, Josh, right? With centimeters, inches, meters, right? Miles, light years. There are multiple ways of measuring angles. Degrees, where there's 360 degrees in a circle, is the thing that you're probably most familiar with. But there's also what's called radians, and radian mode is when your calculator is working in a different unit of measure. So it was thinking 32 radians and not degrees, and you might be able to change that, I believe. Yeah, here, you can change from degree to radian or to gradient, I believe is what that is. But radians are a different type of measurement, and that is not the one that you need to worry about in a geometry class. But either way, this is what we end up getting when I type in 11 divided by tan of 32. I get an approximation. You should reference the shape. If my number was somehow smaller, then I would have suspected I did something wrong. I might have done tan 32 divided by 11 instead. Okay? So what you're going to want to do is make sure that it makes sense with respect to the shape. So let's do another couple examples from the monitoring progress on this. So it's all about setting up the right ratio, first of all. So tan of what angle is equal to what ratio? Tan of what angle? All right, so here, my angle is 61 degrees. Here, my angle is 56 degrees. All right? And the opposite from the 61 is 22. And it's always the opposite over adjacent. So the adjacent leg this time is the x. All right, so once I set up the correct ratio, I can now solve it using cross multiplication or any other algebra that I know. So I'll set it up with cross multiplication. I think that sometimes is the easier way to do it. So I'll have x times tan 61 is equal to 1 times 22, which is 22. I would divide both sides by this number, tan 61, which is some decimal number. Right? It's just a ratio. And I'm going to get x is approximately, and I would type that in my calculator. Looks like I get 12.2. Actually, that's a weird... All right, over here. What is the opposite from 56's perspective? X. And what is the adjacent? 13. That is correct. So now, to solve for x here, guys, check this out. It's probably easier just to multiply both sides by 13 instead of doing the whole cross multiply trick this time. Now, as a student was working on some of these earlier, they multiplied 13 by 56. Do not do that. Do not do that. We can't distribute. I didn't say who it was, but it was just a good common mistake to avoid on a new concept. So x is going to equal 13 times tangent of 56. And so you're going to want to type that into a calculator like so. And I believe I get about 19.3. So make sure that you guys can get that. So the idea is set up the ratio, and then solve for x, and then reference either a table or a calculator or a spreadsheet to be able to do this. Friday. That's why we want to make sure we practice this. So guys, check this out. Shh. Yeah, round it up to 19.3. All right, quickly. Work with me, friends. All right, use a special right triangle to find the tangent of a 60-degree angle. Gentlemen, quiet, please. So, in a 30, 60, 90. Ty, come on, man. You're working against me here. I've got 1 is the length of the shortest leg. How do I go from the short leg to the hypotenuse? I just picked it. It says use A. Yep. Yeah, double it. And then how do I go from the short leg to the long leg in a 30, 60, 90? You got it. So this is the easiest one, but you could have also picked different values for your starting number. So if I want to find the tangent of 60 degrees, I would have tangent of 60 degrees is equal to, so from this perspective, the opposite is the square root of 3, and the adjacent is what number? 1. Why isn't the adjacent the 2? Oh man, you guys are good. You guys are good. I thought I was going to stump you. And so guys, tangent of 60 degrees is the ratio of the square root of 3 to 1, or just plain old square root of 3. All right, and that's what it will always be. The ratio of the opposite to the adjacent will, right? Aiden, you with me? All right. So this is what it will always be. And so this allows us to solve all sorts of problems that we would not have been able to solve using the Pythagorean theorem. So here's just a little piece of terminology that you might need to know for this next one. You will need to know for this next problem. Angle of elevation. And so we were able to solve like triangles with rivers and stuff, and with Napoleon back in the day using similar triangles or congruent triangles. Here it says the angle of elevation that an upward line of sight makes with the horizontal is called the angle of elevation. All right, so with this problem, the angle of elevation would be this 59 degrees, like we see right here. Right? And if I want to estimate the height of this, I could, with a protractor or with surveyors, right, tools, right, I'd be able to find an angle measure, pointing it at the top of a tree. I can measure my distance to the base of the tree because I can walk across the ground, but I wouldn't have been able to so easily measure the height of the tree because maybe I'm not good at climbing, or I'm still terrified of that time in 8th grade when I fell out of a tree and broke my arm and never played soccer again. It happened the same, I don't know. Just happened. Just happened. So tangent of 59 degrees. What is the opposite of, what is the opposite, Tyler, of the 59 degree angle's perspective? That would be the H, right? So tan of 59 is equal to H. And the adjacent is the 45, 45. So to solve for H, we'd multiply both sides by 45. And I'm going to get H is exactly 45 times the tangent of 59 degrees, not radians, degrees. And H will approximately be whatever that is when I plug it in to a calculator in the correct mode. So that's 74.9. And they said find the height of the tree to the nearest foot. So this tree is roughly 75 feet tall. Right, Lauren? Right. So yeah. So that's the way it works. It's all about set up the proportion and then solve using your algebra. All right, thanks for watching, Internet friends. Have a great day.